Welcome to the comprehensive guide on Internet of Things interview questions. IoT, or Internet of Things, is rapidly transforming how devices communicate and interact with each other. Today's session covers the core concepts you need to master for technical interviews. IoT encompasses four fundamental areas: sensors for data collection, connectivity protocols that enable communication, edge computing for real-time processing, and connected device ecosystems that work together seamlessly. These concepts form the foundation of modern IoT systems and are frequently discussed in technical interviews. Understanding these areas will help you confidently tackle any IoT-related questions during your interview process. Internet of Things, commonly known as IoT, refers to a network of physical devices embedded with sensors, software, and connectivity capabilities. These devices can exchange data and interact with other devices and systems over the internet. The key components of any IoT system include physical devices like smartphones, sensors, and smart appliances, connectivity through various protocols, data that flows between devices, and cloud infrastructure for processing and storage. Think of IoT as creating a digital bridge between the physical and digital worlds. Everyday objects become smart and connected, enabling them to collect information, communicate with other devices, and provide valuable insights for better decision-making. Sensors are the eyes and ears of IoT systems, responsible for collecting data from the physical environment. There are several types of sensors commonly used in IoT applications. Temperature sensors measure ambient or device temperature, making them essential for climate control and monitoring systems. Humidity sensors monitor moisture levels in the environment, crucial for agriculture and weather stations. GPS sensors track location and movement, enabling applications like vehicle tracking and asset management. Camera sensors capture visual data and images for security and monitoring purposes. Sound sensors detect audio levels and patterns, useful for noise monitoring and voice recognition. Motion sensors sense movement and acceleration, commonly found in security systems and fitness trackers. Each sensor type serves specific purposes, and choosing the right sensor depends on your application requirements. Communication protocols are the backbone of IoT connectivity, enabling devices to exchange information reliably. MQTT, which stands for Message Queuing Telemetry Transport, is a lightweight messaging protocol designed for devices with limited bandwidth and power. It uses a publish-subscribe model and is ideal for IoT applications. HTTP and HTTPS are web-based communication protocols that many IoT devices use to communicate with cloud services. CoAP, or Constrained Application Protocol, is specifically designed for constrained devices with limited processing power and memory. LoRaWAN enables long-range, low-power communication, perfect for devices that need to transmit small amounts of data over long distances. Here's a simple Python example showing how to use MQTT. You import the PAHO. MQTT, client library, create a client instance, connect to a broker host on port 1883, publish sensor data to a specific topic, and then disconnect. Edge computing represents a paradigm shift in how IoT data is processed and analyzed. Instead of sending all data to centralized cloud servers, edge computing processes data at or near the physical location where it's collected. This approach offers several significant advantages. First, it reduces latency by processing data locally, enabling real-time decision-making. Second, it lowers bandwidth usage by filtering and processing data before sending it to the cloud. Third, it enables real-time processing for time-critical applications. Fourth, it enhances privacy by keeping sensitive data local. Finally, it improves system reliability by reducing dependence on constant internet connectivity. The typical flow involves an IoT device generating data, an edge server processing that data locally, and then sending only relevant or summarized information to the cloud for further analysis or storage. Security remains one of the most critical challenges in IoT implementations. IoT devices face several security vulnerabilities that require careful attention. Weak authentication systems make devices vulnerable to unauthorized access. Data transmission security becomes crucial when sensitive information travels across networks. Firmware update mechanisms must be secure to prevent malicious code injection. Network vulnerabilities can expose entire IoT systems to attacks. Data privacy concerns arise when personal information is collected and processed. To address these challenges, developers implement various security measures. Here's a Python code example demonstrating secure IoT communication. You import SSL and hashlib libraries, create an SSL context using createDefaultContext for encrypted connections, and implement a hash data function that uses SHA-256 to hash sensitive data before transmission. These practices help protect IoT systems from common security threats. Major cloud service providers offer comprehensive IoT platforms to help developers build and manage connected device solutions. Azure IoT Core is Amazon's managed cloud service designed specifically for connected devices. It provides robust device management capabilities, intelligent message routing, built-in security features, and seamless integration with other AWS analytics services. Azure IoT Hub is Microsoft's comprehensive IoT platform offering bidirectional communication between devices and the cloud, automated device provisioning, edge computing capabilities, and powerful AI integration features. Google Cloud IoT provides a device management platform focused on real-time data processing, advanced machine learning capabilities, global network infrastructure, and seamless integration with BigQuery for data analysis. Each platform has its strengths, and choosing the right one depends on your specific requirements, existing infrastructure, and technical preferences. IoT systems follow a layered architecture approach that ensures scalability and maintainability. The device layer consists of sensors, actuators, and embedded systems that interact directly with the physical environment. These devices collect data and perform actions based on received commands. The connectivity layer handles communication between devices and includes various protocols like Wi-Fi, Bluetooth, cellular networks, and specialized IoT protocols. This layer ensures reliable data transmission across different network types. The data processing layer encompasses both cloud services and edge computing infrastructure. It's responsible for analyzing, storing, and processing the massive amounts of data generated by IoT devices. The application layer provides user interfaces, analytics dashboards, and control systems that allow humans to interact with and manage the IoT ecosystem. The typical data flow moves from smart devices through network infrastructure to processing systems, creating a seamless connected experience. Preparing for IoT interviews requires understanding both theoretical concepts and practical applications. Common technical questions include explaining the difference between IoT and machine-to-machine communication, where IoT focuses on internet connectivity and broader ecosystems, while M2M typically involves direct device communication. Interviewers often ask about MQTT protocol advantages, such as its lightweight nature, publish-subscribe model, and reliability for constrained devices. Edge computing benefits are frequently discussed, including reduced latency, improved reliability, and better data privacy. Security challenges questions focus on authentication, data encryption, and network vulnerabilities. Protocol comparison questions test your understanding of when to use different communication methods. To succeed in IoT interviews, understand real-world use cases and provide concrete examples. Know the trade-offs between different protocols and technologies. Always discuss security implications in your proposed solutions. Explain scalability and performance considerations for large deployments. Prepare hands-on coding examples that demonstrate your practical knowledge. Congratulations on completing this comprehensive IoT interview preparation guide. Let's recap the key takeaways that will help you succeed in your interviews. First, understand IoT architecture layers and how they work together to create connected solutions. Second, master the various connectivity protocols and know when to use each one based on specific requirements. Third, remember that security is paramount in IoT systems and always consider security implications in your designs. Fourth, understand edge computing advantages and how it improves IoT system performance. These fundamental concepts form the core of most IoT interview discussions. Remember to practice explaining these concepts clearly, provide real-world examples, and demonstrate your understanding through practical scenarios. The IoT field offers exciting opportunities as more industries adopt connected device solutions. With solid preparation and understanding of these core concepts, you're ready to ace your IoT interview. Good luck with your interview journey.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.